In this tutorial, we will be doing a review for the final exam for Chem 111. On this particular part of the review, we're going to be focusing on significant figures and temperatures, along with some other general definitions. For instance, chemistry could be defined as the way we understand the changes of matter. So, for instance, the atoms, the changes that they undergo, the bonds that they break, and the bonds that they form to create something new. That is what chemistry is all about, just trying to follow that process. Scientific law versus scientific theory. A law is a generalization of common observations. So, for instance, gravity is a law. We know that everything falls to the earth because of gravity. The theory, the scientific theory, is a way of trying to explain the law. You cannot really disprove a theory because all you can do is kind of rearrange the thoughts. You can't prove it right, you can only prove it wrong. So the scientific law is a general observation. Scientific theory is the explanation behind it. Chemical changes versus physical changes. Chemical changes, we're looking at something that either A, cannot be changed back, or at least not very easily, or it's not the same thing when you're done. To give you some examples, for instance, ice. If you take ice, put it on the counter, and it melts, you can change it back pretty easily. You can put it back in the freezer and make it solid again, and it's back to ice. Whereas if you cook an egg, for instance, if you fry an egg, you cannot unfry an egg. So therefore, that's a chemical change. So if you can't reverse something, at least not very easily, or if it's not considered the same thing when you're done, then it's considered a chemical change. Another example would be like a piece of paper. If you burn a piece of paper, it's not considered a piece of paper anymore. It's not considered ash. It's not the same thing. You cannot change it back into a piece of paper. That's a chemical change. Whereas if you take a piece of paper and rip it in half, it's still considered paper. They're just smaller pieces of paper. So therefore, because it's still considered the same thing, that's a physical change. That's not a chemical change. Matter is anything that has mass and takes up space. All the atoms are what's making up the matter. And the conservation of matter is the fact that matter is neither created or destroyed. So another thing, words, things don't just appear and disappear. They actually have atoms that go from one place to another. The biggest issue with that and what people see is when we form a gas during a chemical reaction. One common example is if you're sitting around a bonfire and you put a whole bunch of logs in the fire, but then when it's all done, all you see is ash. And it's a lot less. Well, where did those atoms go that were there originally if matter is neither created nor destroyed? Well, it's just changed forms. It's changed into water and carbon dioxide. And the water vapor gets absorbed into the air, and the carbon dioxide floats away. So in either case, you're left over with items that are in the air now rather than in the pile. And that's why it's seems like so much less. The SI units you want to make sure to memorize. This is called the International System of Units. This is what the scientists use. They don't use metric, they use SI. Kilograms is the unit for mass. Notice that it's kilograms and not grams. That's a very common mistake amongst students. M is meters, and that's for length. Seconds is for time. And kelvins is for temperature. Notice that's kelvins and not degrees Celsius. Alright, so let's talk about significant figures. With significant figures, the thing that really confuses people are the decimals and the zeros. So I break it into leading zeros and trailing zeros, and it all depends on whether or not there is a decimal. So with the decimal, the leading zeros never count, whether it's with a decimal or not. So if we look over here, these zeros in front, those are zeros that lead up to another number. Those never count. With the decimal, the trailing zeros do count. Trailing without do not count. Alright, so once again, let's look at our numbers, our examples. You see these zeros right here? Because of this decimal, those zeros do count. Whereas down here, these trailing zeros here, those do not count because there is no decimal written. If you actually see a decimal actually written, then it counts. So here, we have 5 significant figures here. These first 3 plus those 2 count because of the decimal. Here we only have 3 because these zeros out front don't count. When it's in scientific notation, all 3 of those numbers count because no matter what, you're going to have a decimal there. For this next one, those 2 at the end don't count because of the fact that there's no decimal, so there's only 4 here. The next one, these leading zeros do not count because leading zeros never count. There's no zeros at the end, so we don't have to worry about that, so that gives us 4. And then finally, with this scientific notation, notice the decimal here. No matter what, with scientific notation, you're going to have a decimal. Because of that decimal, those zeros do count. So once again, you have 4. So let's take a look at adding and subtracting numbers with significant figures. So here, we're going to subtract those numbers. There's 2 sets of rules. One's for adding and subtracting, one is for multiplying and dividing. For adding and subtracting, we're going to be looking at the place value. For multiplying and dividing, we're going to look at the quantity of significant figures. So, adding and subtracting, you line it up just like you did in elementary school. And you subtract it out. This comes out to be 2,1,7,0,8,03. Now you want to look at your place value. This last 1 is the last significant figure for the first number. This 7 is the last significant figure for the second number. So I'm going to compare those two. Whichever one is furthest to the left is where I'm going to cut off the number. So here's the 1, that's where I'm going to cut the number off. So 1.170, that 3 goes away. If by chance your number ends over here, it becomes a 0. If it's before the decimal, the other numbers become a 0. You don't just leave it off, because there's a big difference between 21 and 2100. Alright, so for multiplying and dividing, you're going to count the number of significant figures in each number. So 2.5 times 3.42 comes out to be 8.55 when you put it in the calculator. There's 2 numbers here, and there's 3 numbers here. You're going to take the fewer of the 2. So there should be only 2 numbers in your final answer. So your final answer is going to be 8.5. We're going to do the same thing with scientific notation. 4.52 times 10 to the negative 4 divided by 3.980 divided by 10 to the negative 6. If we actually do that division into the calculator, it becomes 113.5678. There's 3 numbers here. There's 4 numbers here. So we're going to take the fewer of the 2 numbers, which is 3. So I'm going to make that 114. Notice here I kept it at 0.5. It doesn't matter if it's 0.5 or 0.6. What they typically do is they look at the next number. So since the next number is a 0, I kept it at a 5. But I doubt that we're going to get that far into it. One other thing to keep in mind is how to put it into your calculator. So when we look at this, never ever put times 10 into your calculator. You will get the question wrong. I guarantee it. Instead, make sure you use EE or EXP. It might be, and it probably is, a second function on your calculator. If you have a scientific calculator, it will be there. You just might have to look for it a little bit. If you have problems finding it, make sure you ask your teacher. Alright, so temperature conversions. That's the last thing we're going to do for this review. We have 2 equations for temperature conversions. That's degrees Fahrenheit is equal to 9/5 degrees Celsius plus 32. And Kelvin is equal to degrees Celsius plus 273. Alright, so we have 10 degrees Celsius and we're converting it to Fahrenheit. So we have Celsius and Fahrenheit in this equation. So that's the one we're going to use. So degrees Fahrenheit is equal to 9/5 of 10, because it's 10 degrees, plus 32. So 10 times 9 is 90, divided by 5, plus 32. That comes out to be 50 degrees. The next one is 32 degrees Celsius to Fahrenheit. So we're going to use the exact same equation. So 9/5 of 32 comes out to be 9 times 32 divided by 5, 57.6. Plus 32. It tells us that the temperature is going to be 89.6 degrees Fahrenheit. If we're concerned about significant figures, notice we have 2 significant figures in the very first number. So that means we're going to have 2 in the end. We're going to round that to 90 then, because of the 6 rounds it up to a 0. However, we want to make sure that 0 counts, so we're going to put a decimal at the end. Alright, and these are going to be the last 2 for this video. 101.0 degrees Fahrenheit. And we're trying to get to Kelvin. Remember, we have 2 different equations. Degrees Fahrenheit is equal to 9/5 degrees Celsius plus 32. And Kelvin is equal to 273 plus degrees Celsius. So we have Fahrenheit to Kelvin. That means we're going to have to use both equations in this question. So 101.0 degrees Fahrenheit is equal to 9/5 degrees Celsius plus 32. Alright, so let's figure out Celsius, and then we're going to put Celsius into the other equation. So the very first thing we want to do is get rid of this 32. This is the part that people usually get confused with. So I'm going to do 101.0 minus 32. That's going to come out to be 69.00 degrees Fahrenheit is equal to 9/5 degrees Celsius. So it's going to be 69 times 5 divided by 9. That gives us 38.33 degrees Celsius. Now we're going to take this number and put it into Kelvin equation. So Kelvin is equal to 273 plus 38.33. That comes out to be 311 kelvins. And the last problem we're going to do is a really simple one. We're just going from kelvins to degrees Celsius. So we only use this equation here. So 322 kelvins is equal to degrees Celsius plus 273. Notice I say degrees Celsius plus 273, 273 plus degrees Celsius. It doesn't matter what order you have them in because we're adding here. So we're going to subtract 273 from both sides. And that gives us an answer of 49 degrees Celsius. And that is the first part of your review.